So today, let's dive into a force that shapes pretty much everything around us, from the weather outside to the phone you're probably holding. We're talking about heat. But the real secret here, the thing that changes everything, isn't just what heat is, but how it moves. If you can get your head around that, you'll start to see the world in a completely new way. All right, let's start with a classic summer mystery, one you've probably experienced yourself. Picture a bicycle that's been sitting out in the sun. You touch the metal frame and wow, it's scorching hot, right? But then you touch the plastic handlebar grips and they just feel warm. So how is that possible if they've both been in the same sun at the exact same temperature?
To solve this little puzzle, we've got to think like scientists, and that means we need to get a handle on two really important words they use: heat and temperature. Now, they might sound like the same thing, but believe me, the difference between them is the key to everything. Okay, let's break this down. Temperature. Well, that's just a measurement. It's how much energy the tiny little particles inside an object have. You can kind of think of it as how fast its atoms are wiggling and vibrating. Heat, on the other hand, isn't something an object has. It's the movement of that energy. It's the energy in transit, moving from a warmer place to a cooler place.
And that flow of energy, that's what we call heat transfer. And it's one of the basic rules of the universe. Heat always moves from a warmer object to a cooler one. It's kind of like a river flowing downhill. It just keeps going until everything evens out and reaches the same temperature. That's a state that scientists call thermodynamic equilibrium. So, we've established that heat is energy on the move. But how does it actually travel? Well, it turns out there are three main ways it gets from one place to another. Let's think of them as the three main suspects in our bicycle mystery. First up, we've got conduction. This is just heat transfer through direct touch. So imagine you put a metal pan on a hot stove. The burner gets the atoms on the bottom of that pan vibrating like crazy. And what do? They bump into their neighbors, which makes them start vibrating, and they bump into their neighbors, and so on, all the way up the handle. It's basically a chain reaction of jiggling atoms. And that brings us right back to our bicycle. The whole reason the metal feels hotter is all about how good it is at that atomic chain reaction. It's a property called thermal conductivity. And I mean, just look at the numbers here. They tell the whole story. Aluminum has a thermal conductivity of 205. Wool is just 0.07. That is a massive difference. So when you touch that hot metal frame, it's an amazing conductor, and it just dumps a huge amount of heat into your hand really fast. The plastic grips, they're what we call insulators. They transfer that same amount of heat, but they do it much more slowly. So the metal doesn't actually have more heat, it just gives it to you way faster. Mystery solved. Okay, on to our second suspect, convection. Now, this is how heat moves through fluids, so liquids and gases. When you boil a pot of water, the water at the very bottom gets hot first. It expands, becomes less dense, and it rises. At the same time, the cooler, denser water from the top sinks down to take its place, gets heated up, and rises too. This whole thing creates a circulating current that heats the entire pot. It's the same reason blowing on your hot coffee works. You're using convection to push the hot air away and replace it with cooler air. And our third and final suspect is radiation. Now, this one is really cool. This is heat that travels as invisible waves, kind of like light waves. What's amazing is that it's the only kind of heat transfer that can move through the total vacuum of space. It's exactly how we feel the warmth of the sun, even though it's millions of miles away. It's also why you can feel the heat coming off a grill without ever touching. So there's our lineup: conduction, convection, and radiation. But for scientists and especially for engineers, just knowing that heat moves isn't really enough. The question they're always asking, the really important one, is how fast?
This is where two big fields of science kind of meet up. You have thermodynamics. Think of that as the big picture boss. It tells you the total amount of energy that can move from point A to point B. But then you have the science of heat transfer. That's all about the details of the journey. It's the science that tells us how fast that energy is actually moving.
Here's a really great way to think about it. Thermodynamics can tell you how much energy an object has at the top of a cliff versus the bottom. But heat transfer is like asking, how fast is it falling? And for engineers, that speed is absolutely everything. It's what lets them design systems to control heat, whether it's inside a car engine or on a tiny little computer chip. Because, see, once you understand the rules of how heat moves and how fast, you can start to control it. And that's where science becomes engineering. That's when you can start to design amazing things that solve real-world problems. So let's take a simple, really practical challenge. You need to design a lunchbox. The goal? Keep your food cold and safe to eat. and that means keeping its temperature below 4 degrees Celsius, even if the lunchbox is sitting in a warm room. So, how would an engineer tackle this? Well, they'd follow a logical process. First, what's the goal? Simple. We need to minimize, or slow down, heat transferring from the outside in. Okay, what are the constraints? It's got to be portable, can't cost too much, you know the deal. With those rules in place, we can start choosing our materials. And then, finally, build and test a prototype.
So, which materials do we choose? Well, to keep heat out, we need the total opposite of that metal bike frame, right? We need thermal insulators. We need materials with super low thermal conductivity that transfer heat very, very slowly. Things like foam or wool or even just cloth.
And this is so much bigger than just lunchboxes. The exact same principles of controlling heat transfer are used to design pretty much everything. We're talking about the insulated jacket that keeps you warm in the winter, the cooling system that stops your computer's brain, the CPU from overheating, even giant greenhouses that have to perfectly control the temperature for plants to grow. It's all the same science. Understanding how heat moves, it's like having a design superpower. It lets engineers build everything from the spacesuits that protect astronauts in the freezing cold and searing heat of space, to the smartphones that we carry in our pockets every single day. It all comes back to those 3 simple ideas: conduction, convection, and radiation. So now that you know the rules, what will you design?